Hello everyone, I'm Wenjun alongside Kuma&Wenjun, and we're here to introduce our flood probability estimation model for Calgary and Edmonton. In 2013, Calgary faced its most devastating flood in over a century, prompting our focus on this site. A mix of heavy rainfall and snowmelt led rivers to surge, causing widespread damage and highlighting the critical need for advanced flood risk management strategies. Flood prediction model is vital in addressing this need. It can provide a foundation for emergency planning, community warnings, and infrastructure reinforcement, aiming to minimize the impact of future floods. And it's designed not just for forecasting in Calgary, but can be adapted for similar urban areas at risk of flooding. In this project, we aim to develop a predictive model that estimates the probability of flood inundation in the cities of Calgary and Edmonton, Alberta. Using open data sources, we incorporate rainfall data, DEM, hydrology information, and permeable surface data to determine areas most at risk of flooding. Starting with a 500 x 500 feet fishnet, we incorporated elevation, rainfall, permeability, and distance to water bodies to analyze flood risks. We also merged the fishnet with inundation data to visually differentiate between affected and unaffected zones, using light and navy blue for clarity. The subsequent analysis using bar plots allowed us to examine the relationship between environmental variables and flood impact. These insights showed that areas with higher permeability, proximity to water, and lower elevations are more susceptible to flooding in Calgary. We partitioned the Calgary dataset to develop our model, using 70% for training to ensure thorough learning, and set aside 30% for testing, and the model's significant predictors indicated that higher rainfall and lower elevations increase flood risks. To validate the model's predictive accuracy, we utilized histograms and density plots. The histogram in red shows most predictions cluster at lower flood probabilities, implying minimal risk for the majority of Calgary. The density plot distinguishes between the likely non-inundated areas in light blue, which our model confidently identifies, and the potential inundation zones in red, where predictions vary more, reflecting a degree of uncertainty for areas at a greater risk of flooding. Our flood prediction model was rigorously tested for accuracy. While it excelled in identifying non-flooded regions with over 96% specificity, we found room for improvement in detecting actual floods, as reflected by a lower true positive rate. Despite this, the model achieved an 81% accuracy rate overall. Our next steps focus on enhancing the model's sensitivity to better forecast flood events. The ROC curve analysis, marked by a steep climb in the graph, demonstrated the model's strong capability to differentiate between areas at risk and not at risk of flooding, supported by an AUC score of 0.85, vital for informed flood management decisions. To solidify our confidence in the model, we conducted extensive cross-validation, revealed through histograms. An average accuracy of 82.7% from these tests reassures us of the model's robustness. But a kappa statistic of 0.166 indicates that there's still potential to refine its predictive consistency. And by mapping predicted probabilities against known flood areas, illustrated here in orange, we can see a strong correlation between our model's high-risk zones and historical flood events. This correlation underscores the accuracy and practical value of our model. Our final step brings us to the error map. The error map provided a spatial view of our model's prediction outcomes, identifying accurate predictions and areas for improvement. True positives, highlighted in red, are areas our model accurately predicted as flooded. False negatives, shown in dark blue, are areas that were flooded but missed by our model. Lastly, we expanded our predictive reach to Edmonton, employing the model under scenarios of increased rainfall. The resulting map pinpoints areas in vivid orange where flood risks are higher, emphasizing the need for focused flood mitigation efforts in these specific locales.